Today's module 2A, we'll go through solving systems of equations by graphing. Over the course of this week, we'll also look at solving systems of equations by elimination and systems of equations by substitution. So today's class will focus on solving systems of equations by graphing. We'll also look at how to set up equations from word problems. In each of the seminars this week, we'll begin by looking at the same three systems of equations: set 1, set 2, and set 3. When we say we're trying to solve these systems, what we're trying to do is to figure out if there are any values, any value of x and y that we can sub into both equations and make them both satisfied simultaneously. For system of equations 1, you'll notice that if we sub in x equals 4, y equals 1, both the first equation, x minus 2y is equal to 2, is true, as well x plus y equals 5 is true. That is our goal when we're solving a system of equations, is to try and figure out values that we can sub into both equations and make them true at the same time. When solving systems of equations by graphing, what we want to do is graph both equations on the same set of axes and determine where they intersect. You'll notice on this particular set of axes, each of the grid lines represents 1. On the x-axis and on the y-axis. With this labeling in place, then you can confirm that the points do in fact, or that the lines do in fact intersect at the point 4, 1. Okay. I'm going to review how these lines were graphed. To begin with, let's think about which of the lines is represented in green. Which of the equations for which line is represented in green? If we think about the line x plus y is equal to 5, you can confirm that the x-intercept, which is found by subbing in y equals 0 into the equation, is 5. Similarly, the y-intercept, which is found by subbing in x equals 0 into the equation, is also 5. If you were to put the y-intercept on the y-axis, the x-intercept on the x-axis, and combine them with a straight line, you get the green line that's shown. Similarly, the equation x minus 2y is equal to can be found to have an x-intercept of 2 and a y-intercept, which we find again by subbing in x equals 0, of negative 1. Combining the x and y-intercept with a straight line leads to the red graph that's shown. Some of you may have experienced graphing equations from the form y equals mx plus b. If we rearrange the equation into the form y equals mx plus b, we would move the x value to the opposite side of the equation, divide both sides by negative 2. We get negative 1 plus 1/2 x, or y is equal to 1/2 x minus 1. This line has a y-intercept at negative 1 and a slope of 1 over 2. That means a rise of 1 for a run of 2. And again, we could make several points and then connect them in a straight line. How you generate the graph is based on your own comfort level. I recommend using X and Y intercepts because oftentimes the algebra is easier and leads to fewer errors. But the most important thing about the method that you choose is it's one that you can do quickly and accurately. If you really like making a table of values, you can do that. But again, when the lines are given to you in standard form, it requires a bit of work to get the lines in the form y equals mx plus b to be able to generate that table of values. Many of the systems of equations we're going to deal with in the course will have one solution, one intersection point, just like the example we've looked at. But you may wonder, do all lines intersect? And the answer is no, right? If the lines are parallel, right, or they have the same slope, then they will not intersect. In class today, we went through these other examples at our own pace. I would recommend that you pause the video at this point and try to solve question 2 by graphing. Find the x-intercept and the y-intercept for both of the equations. Graph the lines, and then resume the video to check your answers. Hopefully, you've tried the work yourself, and you can confirm your results below. So we will find the x and y intercepts for both equations. We begin with the line x plus 2y is equal to -4. For the x-intercept, we're going to sub in, y is equal to 0. That means our point goes through the point -4, 0. We could add that to our graph. Next, we'll find the y-intercept for the same line. To find the y-intercept, remember, we sub in x equals 0. That leads to a value of -2, and means that the point 0, -2, will be on our graph. I'm going to quickly draw a set of axes here. X, Y. For simplicity, I'm going to draw in some tick marks by hand. So the point -4, 0 is on our graph, as well the point 0, -2. I'm going to join those points with a line. My graph is now updated. X, 2y is equal to -4. If I repeat that process using the second equation in our system, 2x plus 4y is equal to 8, I find the x-intercept is equal to 4. Similarly, we can find the y-intercept is at the point 0, 2, and graph the line. Now that the lines are graphed, we see this is an example of two parallel lines that do not intersect. We could tell by inspection, actually, that the lines are parallel based on the fact that the ratio between the coefficients between the x and the y terms is the same in both equations. The ratio between the x coefficient of 1 and the y coefficient of 2 is 1 to 2, and it's the same when the coefficients are 2 to 4. Practice trying question 3. What you should find here is not only are the lines parallel, but they actually it's the same line represented two different ways, because not only are the x and y variables in proportion to each other, but the constant is 2. between the first equation and the second equation, all of the values are halved. Question 2 represents what we call a system that has no solutions. The lines do not cross. Question 3 is actually an example of a system that we say has infinite solutions because the lines cross everywhere. Okay. Moving on. If you want to practice your skills, again, there's not a whole lot of homework questions in here. We're going to set up equations on the next page, and you can try them out. If you want to generate your own practice sheets, you can use this link. There are options to solve systems of equations by, and you can solve by graphing. That's what we're doing today. We're going to do solving by elimination later on in the week, and then we're going to solve by substitution on Friday. Okay. So the other thing we want to look at today is solving systems of equations represented by word problems. You have 2 examples here. The first one, we have an exam worth 20 points containing 13 questions. Some of the questions are worth 1 point and some are worth 2 points. We want to know how many 1-point questions are on the test and how many 2-point questions are on the test. The first step when setting up a question type like this is to define our variables. When we define our variables, we ask ourselves what we're trying to find. So we'll let x equal the number of 1-point questions on the test, and y equal the number of 2-point questions on the test. Next, we'll generate our equations based on the information that we're given. So we know that there are 13 questions on the test. This means that x plus y must be equal to 13. The other bits of information that we're given are about the number of points. We know that in total, there are 20 marks on the test. Since x questions are worth 1 mark, they will be represented just by x, and y questions are worth 2 marks each, so they would be represented by 2y. X plus 2y has to be equal to 20. If we solve this system of equations, we find out that x and y are both equal to 6 and 7, respectively. I'll leave that as an exercise for you. You can graph the line x plus y is equal to 13, as well as the line x plus 2y is equal to 20, and see that the lines intersect at the point 6, 7. For question 2, we have information about purchases that are being made. We want to know how much the box of surgical gloves cost, and we want to know how much a box of patient table paper costs. So we'll let x and y be equal to the price of 1 box of latex surgical gloves and 1 roll of patient table paper, respectively. We'll use the information from each invoice to generate our questions. The first invoice has 12 boxes of latex surgical gloves and 4 rolls of patient table. The total of that invoice is $100. The second invoice has 6 boxes of surgical gloves and 3 rolls of patient table paper and totals $60. You can check that the ratio between the coefficients between x and y are not the same in both equations, and there is a single solution to the system. It works out that the cost of 1 box of latex surgical gloves is $5, and the cost of 1 roll of patient table paper is $10. I'll leave it to you as an exercise to graph the lines 12x plus 4y is equal to 100, as well as 6x plus 3y is equal to 60, and confirm that the lines intersect at the point 5, 10. If you have any questions, please don't hesitate to come to my office or visit Math Drop-In. Take care. Bye.